Okay, so we have line 18a3n, Aether drag velocity, separate particle matter, patent WOW SETI, part number 117, Brazilian signal. Now, my search for binomial expansion, NASA leads me to this, February 4th, 2012. I see this mathematical equation and it makes me think of V for velocity. So I click on it and it brings me to Aether drag hypotheses. I see the words dragged and speed of light and I think of the neutrinos experiments at Grant Sassel's findings. There's a mathematical equation I found. I looked up hypotheses is a proposed explanation for a phenomenon. This is binomial expansion using Pascal's triangle. Consider the following expanded powers of A and B. That's what it looks like. So Aether wind stands out here. So the Aether drag hypothesis, sorry, I'm really tired. The Aether drag hypotheses dealt with the question whether the luminiferous ether is dragged by or entrained within moving matter. According to the first variant, no relative motion exists between Earth and ether. According to the second one, relative motion exists, and thus the speed of light should depend on the speed of this motion, aether wind, which should be measured by the instruments at rest on Earth's surface. Specific Aether models were invented by Augustin Jean Fresnel, who in 1818 proposed that the ether is partially entrained by matter. And that's this fella here. The other one was proposed by George Stokes. And this is George Stokes. Sir George Stokes, BT. Okay. Well, Fresnel's almost stationary theory was apparently confirmed by an experiment in 1851. Stokes' theory was also confirmed. So they had two different theories and both were confirmed. This contradictory situation was resolved by the works of Hendrik Antoon Lorentz, whose Lorentz ether theory banished any form of ether dragging, and finally with the work of Albert Einstein, 1905, whose theory of special relativity doesn't contain the ether as a mechanical medium at all. Partial ether dragging in 1810, Francois Arago realized that the variations in the refractive index of a substance predicted by the corpuscular theory would provide a useful method for measuring the velocity of light. So we're talking about the velocity of light, and that comes up with the space platform. I forget what it's called. That's going to be coming up soon. In physics, a velocity addition formula is an equation that relates the velocities of moving objects in different reference frames. So this is a little graph here. So space-time geometry and velocity addition. We start by considering the space-time representation of the two objects B and C moving relative to A. They are both moving away from A, and C is moving faster than B, referred to Figure 1. In Figure 1, the axis of motion for each moving object are shown. PB is the motion axis for object B, and PC is the motion axis for object C. PB and PC. Okay. The dashed lines are reference lines for the purpose of determining the transformation equations for B. To avoid confusion, the reference lines for C are not shown. The lines for C would simply be oriented relative to PC. So the tags coming up here is axis and fluid filter and method of separating entrained particle matter from whatever. Jerry T. Carter, inventors Jerry T. Carter and Joseph Frutasso. And this is a new invention that came up. Patent number 5453117. It was issued back in 1995. The invention is a fluid filter and method of separating entrained particle matter from a moving fluid stream. The fluid filter includes a filter structure for mounting the filter on a supporting surface, a plurality of nested filler frames, and a filtration method carried by each of the filter frames. The filter structure, oh boy, I'm really tired, sorry. The filter structure has a fluid inlet zone and a fluid outlet zone for conveying the fluid stream there through. The nested filter frames are located within the filter structure in spaced apart relation to each other. These guys must have the word filter in here about 20 times. The filtration media are interposed between the fluid inlet zone and the fluid outlet zone of the filter structure, and define on one side, therefore, an upstream filter surface, and on the other side, downstream. I don't know what they're talking about. So here's a diagram if you want to take a look at it. One of the diagrams. And that's what it looks like. Okay, so that's the end of that one. That's number N, and next one's going to be O.